Solar sail propulsion is an advanced space travel technology that uses sunlight or laser beams as a source of propulsion instead of traditional fuel. A spacecraft equipped with a large, ultra-thin reflective sail captures photons from the sun, and as these photons bounce off the sail, they transfer momentum to the spacecraft, gradually accelerating it. Although the thrust is very small compared to chemical rockets, it builds up continuously over time, allowing spacecraft to reach extremely high speeds on long-duration missions. This technology could potentially enable interstellar travel, sending probes to nearby stars in decades rather than centuries. Solar sails are lightweight, require no onboard propellant, and can theoretically operate indefinitely as long as they receive light. Pulsar Fusion Sunbird is a visionary concept for a nuclear fusion rocket engine designed to revolutionize space travel. Billed as a migratory transfer vehicle, the Sunbird is intended to act as a space tug, docking with other spacecraft in low Earth orbit to propel them on long-distance interplanetary journeys. Its core technology is the Dual Direct Fusion Drive DDFD, a compact linear fusion reactor that utilizes an anitronic fusion reaction with deuterium and helium-3 fuel. This process is expected to produce both immense thrust and auxiliary electrical power, with a high specific impulse of 10,000 to 15,000 seconds and a power output of 2 megawatts. The company claims this technology could dramatically reduce travel times, potentially cutting the trip to Mars in half and reaching Pluto in just 4 years. The space elevator concept is a revolutionary vision for future space travel that aims to eliminate the need for traditional rockets, drastically reducing launch costs and making access to orbit far more routine and sustainable. This theoretical megastructure would consist of a tether anchored on Earth's equator, stretching tens of thousands of kilometers into space, with its other end attached to a counterweight beyond geostationary orbit. Using electric-powered climbers, spacecraft and cargo could ascend the tether into orbit without the massive fuel requirements of rockets. Companies like Obayashi Corporation in Japan have announced long-term plans to develop a space elevator by 2050, while NASA and other agencies continue to explore the physics and engineering challenges behind this concept. SpaceX Starship is a next-generation, fully reusable spacecraft designed to revolutionize space travel by significantly lowering costs and enabling large-scale missions to the Moon, Mars, and beyond. Standing at approximately 120 meters when combined with its Super Heavy booster, Starship is the tallest and most powerful rocket ever built, capable of producing 16.7 million pounds of thrust. It is designed to carry up to 150 tons of cargo or 100 passengers in a single flight, making it a key player in future interplanetary colonization efforts. The spacecraft features stainless steel construction, heat shield tiles for atmospheric re-entry, and advanced Raptor engines powered by liquid methane and oxygen, fuels that can potentially be produced on Mars. Polaris Dawn, the first mission of SpaceX's Polaris program, set new records in commercial spaceflight. Launched on September 10, 2024, aboard a Falcon 9 rocket, the Crew Dragon Resilience carried Jared Isaacman, Scott Poteet, Sarah Gillis, and Anna Menon to an altitude of around 1,400 kilometers, the highest Earth orbit since Apollo. Over 5 days, the crew conducted nearly 40 experiments on radiation exposure, microgravity health effects, and decompression risks while traveling through the Van Allen belts. A historic first occurred when Isaacman and Gillis performed a private spacewalk using SpaceX's new EVA suits, built for future Moon and Mars missions. The team also tested high-speed laser-based Starlink communications. The mission concluded with a safe splashdown in the Gulf of Mexico, proving private spaceflight can achieve groundbreaking feats once limited to government program. The O'Neill cylinder is a groundbreaking space habitat concept proposed by physicist Gerard K. O'Neill in the 1970s, envisioned as a massive rotating space station capable of housing millions of people. It consists of two enormous counter-rotating cylinders, each measuring about 8 kilometers in diameter and up to 32 kilometers long, creating artificial gravity through centrifugal force. Inside, the landscape is divided into alternating land and window strips, allowing sunlight reflected from giant external mirrors to simulate natural day and night cycles. These habitats could feature vast green spaces, lakes, and farmland, providing a near-Earth living environment while floating in space. Designed to be self-sustaining, they would generate power from solar energy, recycle air and water, and use materials from the moon or asteroids for construction and radiation shielding. With the potential to house up to 10 million people, the O'Neill cylinder represents one of the most ambitious and realistic visions for large-scale human colonization beyond Earth. Virgin Galactic, founded by Sir Richard Branson in 2004, is a trailblazer in commercial space tourism, offering suborbital flights aboard its spaceplane VSS Unity. The journey begins with the spacecraft carried to an altitude of about 50,000 feet by its mothership, VMS Eve, before igniting its rocket engine to propel passengers beyond 80 kilometers above Earth. The flight provides several minutes of weightlessness and stunning views of the planet's curvature before gliding back for a runway landing in New Mexico. Expected to debut in 2026, this new fleet is designed for higher flight frequency, lower costs, and expanded passenger capacity, paving the way for more accessible space travel experiences in the coming years. Rocket Lab has proposed a streamlined, commercial solution to the NASA ESA Mars sample return mission, aiming to provide a more affordable and faster alternative to the current plan. The company's architecture involves using its in-house, vertically integrated capabilities to build and launch the necessary spacecraft, including a dedicated Mars telecommunications orbiter, an Earth return orbiter, and a Mars entry and descent system with a sample retrieval lander and Mars ascent vehicle. By simplifying the mission design and leveraging proven technologies, Rocket Lab believes it can reduce costs to under $4 billion and return samples to Earth as early as 2031, which is years ahead of and significantly cheaper than the current projections for NASA's program. The Rockwell C-1057, often nicknamed the Breadbox Shuttle, was an unconventional shuttle concept developed by North American Rockwell in the early 1970s. Aimed at shortening the orbiter without sacrificing payload capacity, engineer Harry Scott proposed rotating the cargo bay sideways, producing a squat, boxy silhouette that earned its moniker. Although aerodynamic in theory, the unusual shape posed integration challenges, especially with the external tank and solid rocket boosters, which ultimately kept the design at the proposal stage. This concept never advanced beyond Phase B studies and was never built or flown. Despite that, it became a subject of fascination in aerospace design lore. NASA's X-59K SST Quiet Supersonic Technologue is an experimental aircraft developed with Lockheed Martin to revolutionize supersonic flight over land by eliminating the disruptive sonic boom. Designed with a long, needle-like nose and top-mounted engine, the X-59 diffuses shock waves to produce only a soft thump when breaking the sound barrier. Powered by a General Electric F414 GE100 engine, the 94-foot aircraft can cruise at Mach 1.42 at 55,000 feet. Instead of a traditional cockpit window, it uses an advanced external vision system with high-resolution cameras feeding real-time imagery to cockpit displays. Expected to begin flight tests in 2025, the X-59 will conduct community overflights to gather data for updating global regulations on supersonic travel. paving the way for faster, quieter commercial flights worldwide. The Blue Ring Pathfinder is an innovative orbital transfer vehicle designed to provide a variety of in-space services. Acting as a space tug, it can transport satellites from one orbit to another, often from a deployment orbit to their final operational position. This capability is crucial for optimizing launch services and extending the lifespan of valuable space assets. Beyond simple transportation, the Blue Ring Pathfinder can also perform complex maneuvers such as rendezvous and docking, enabling missions like satellite refueling, in-orbit servicing, and debris removal. Its modular design allows for customization to meet specific mission requirements, making it a versatile tool for a wide range of commercial and government customers. Celeste is a luxurious, eco-friendly space capsule designed by Zafalto and architect Joseph Durand to offer a unique journey to the stratosphere. The capsule, which can accommodate 6 guests and 2 pilots, is lifted by a stratospheric balloon to an altitude of 25 kilometers, well above the cruising altitude of commercial airliners. Its design emphasizes comfort and an immersive viewing experience, with expansive panoramic windows that provide a breathtaking view of the Earth's curvature. The interior, with its minimalist design and a soft color palette of creams and beiges, is meant to be a tranquil, residential-like space. Passengers can relax in intimate cabins, enjoy gourmet, Michelin-starred cuisine, and witness what astronauts call the overview effect, a transformative new perspective on our planet. Towering nearly 320 feet above the launch pad, Blue Origin's New Glenn marks a bold leap toward the future of space exploration. Built as a reusable heavy-lift rocket, it is engineered to deliver massive payloads, up to 45 metric tons, to low Earth orbit while slashing launch costs through booster recovery and reflight. Its power comes from 7 B4 methane-fueled engines on the first stage and 2 high-efficiency B3U hydrogen engines on the upper stage, providing the thrust and precision needed for ambitious deep space missions. The rocket's inaugural flight in early 2025 proved its orbital capabilities, successfully deploying a test payload even though its booster recovery attempt fell short. Designed for versatility, New Glenn is slated to support key projects like Amazon's Project Kuiper satellite constellation, NASA's Artemis lunar missions, and future Mars exploration probes. Hassel, in collaboration with Eckersley O'Callaghan EOC, has envisioned a futuristic Mars habitat designed to support sustainable human life on the Red Planet. This innovative concept focuses on creating a safe, functional, and comfortable living environment for astronauts, capable of withstanding the harsh Martian climate, intense radiation, and dust storms. The habitat design utilizes 3D printing technology with Martian regolith as the primary construction material, reducing the need to transport heavy building supplies from Earth. Its modular structure allows easy assembly and expansion, with interconnected living pods featuring airlocks, workspaces, sleeping quarters, and communal areas to foster teamwork and well-being during long missions. The interior also includes hydroponic gardens that provide fresh food and improve air quality, advanced life support systems, and a modular layout that can be reconfigured as mission needs evolve. Future space travel promises a transformative shift from our current capabilities, pushing the boundaries of human exploration far beyond our solar system. The distant future could see humanity venturing to other star systems, propelled by advanced technologies that overcome the immense challenges of interstellar distances. Concepts like warp drives, which manipulate space-time, or fusion-powered rockets, offering unprecedented speed and efficiency, could become realities. These journeys would not only involve sending probes but also human crews, necessitating closed-loop life support systems and artificial habitats to sustain them for generations. Such ventures would be driven by a thirst for knowledge, the search for habitable exoplanets, and the long-term survival of our species, making humanity a multistellar civilization. This monumental leap would redefine our place in the cosmos, turning science fiction into a tangible, awe-inspiring reality.